Okay, everyone, today we are going to get you prepared for that upcoming test. So here's a video to go over Module 4, Lessons 1 through 6. So for this very first part, I hope your first step always was to define your variable. So for the first one, we are just talking about integers, and in particular, we are going to let it be the first integer. So anytime it deals with consecutive integers, consecutive odd, consecutive even, and so forth, you would always say x is equal to the first integer. So I know if x is my first integer and I want odd integers, to get to the next odd value, I would have to take my original integer and add 2 to it. To get to the next odd integer, I would have to take my original integer and add 4 to it. Remember, the word is in math means equals, and it's equal to 450. Now, if you were stuck on how I got x, x plus 2, x plus 4, think about odd integers. So if I pick 3 odd values, 3 consecutive odd integers, 1, 3, and 5, so if 1 is my first one, if 1 would be x, to get from 1 to 3, don't I have to add 2? And to get from 1 to 5, don't I have to add 4? The next thing I had to do is state if it was linear and nonlinear. So in particular, this one would be linear because my variable is x, and my exponent with every single variable is a 1 in this case. So remember, if it's linear, your exponent would be a 1 or a 0. Next one, 10 subtracted from the reciprocal of a number. First step is to define my integer. In this case, we're just talking about numbers, so I would say x equals a number. Remember, you see the word from, so whenever we deal with the word from, the information that is after the word actually comes first when you're writing it. So it's like these segments or pieces are going to be flipped. So if I start to do that, the reciprocal of a number. So if x is my number, remember the reciprocal just flips it. So if x was my original value, if it's not in fraction form, put it over 1. And if I flip that, 1 over x is my reciprocal. So I would have 1 over x. I see the word subtracted, so I'm going to put my minus sign, and then 10. This is going to be non-linear because my variable was in the denominator. Anytime you have a variable in the denominator, it is nonlinear. The product of 7 in a number. In this case, we're just talking about numbers, so x is equal to a number. Remember, product means multiply, so I'm just doing 7x. This is going to be linear because if I look at my variable, my exponent is a 1. Remember, anytime it's a 1, you don't see it. The sum of 4 consecutive integers is 999. So in this case, x isn't just an integer, x isn't just a number. This time, x would equal the first integer. So I would have x. To get to my next one, I would have to do my original plus 1, then my original value plus 2, and then my original value plus 3. If you're not sure how I'm getting that, think about 4 consecutive integers. Think about numbers, I don't know, 4, 5, 6, 7. If 4 is my first one, to get from 4 to 5, don't I have to add 1? To get from 4 to 6, I have to add 2, and to get from 4 to 7, I have to add 3. Remember, is means equals, and I have 999. This is going to be linear because all of my variables have an exponent of 1. A number multiplied by itself 5 times. So in this case, x is just a number. And remember, if I'm multiplying by itself 5 times, I would have x times x times x times x 5 times. Or you could have x to the 5th power. Now this time, since my exponent is not a 1 or a 0, this expression is nonlinear. The square of the sum of 11 and a number. In this case, we're just talking about numbers. So x is equal to a number. So I'm taking the sum of 11 and a number. So I would take 11 plus x. Remember, save your squares to the very end because I'm squaring this whole entire thing. Since I'm squaring the whole entire thing, that to the 2nd power makes it non-linear. The next one, x in particular this time is my number of games. At admission fee of $15 plus $6 per game. This is linear because if I look at my variable, my exponent is a 1. So when you're doing that part up there, make sure you think about those key phrases or words we made you write down in your notebook or on that note card. That'll help you out when you're studying for this test. So there are, in this case, remember, terms are separated by operations. So I have 1, 2, 3, 4 terms. My constants, I just have one constant. The constant would be, so I have one constant, and in this case it's the -7. And coefficients, I have 3. I have the 4, the 10, and the 2. If we try this one, I have 1, 2, 3, 4, 5, 6 terms. Constants, I have 2, and they would be the 8 and the -10. The coefficients, I have 4. I would have the 15, the 12, the -5, and the other 15. When you're doing these types of problems, make sure you know that your constants and your coefficients have to add to give you your terms. It's a good way to double check. My constants and my coefficients have to add to give me my number of terms, which that works in both cases. I have 1 plus 3 gives me 4, 2 plus 4 gives me 6. Now we are on to your favorite part, solving equations. First step, draw your line down your equal sign. Remember, when we're doing these, we want to isolate the variable. We want to get the variable by itself. Your final step is always multiplication or division. So first thing I'm going to do is subtract 7 from both sides. Those 7s would cancel, so I have 5x equals 35. Remember, the opposite of multiplying by 5 is dividing both sides by 5, and in this case, x equals 7. Next one, the opposite of adding 8, I would subtract 8 from both sides. Those cancel. So I have -6x equals 32 minus 8 is 24. I'll divide both sides by -6. And in this case, x equals a -4. The opposite of adding 8 would be subtracting 8 from both sides. And remember, when you're doing these, what you do to one side, you must do to the other. My 8's cancel, so I have x divided by 7 equals 4. The opposite of dividing by 7 would be multiplying both sides by 7. When I do that, my 7's would cancel, so x equals 28. Opposite of subtracting 5, I would add 5 to both sides. These cancel, so I have x divided by 3 equals negative 15. The opposite of dividing by 3 would be multiplying both sides by 3, and in this case, x equals negative 45. If we keep it going, the opposite, now this is one a lot of kids get confused. Here is the value I have to get rid of first. It's a positive 8. So the opposite of a positive 8 would be subtracting 8 from both sides. My 8's cancel. Make sure you bring down your negative 2, the negative sign with the 2x, equals negative 22. I'm going to divide both sides by negative 2, and in this case, x would equal 11. Same thing here, the opposite of a positive 4 is subtracting 4 from both sides. Those cancel, so I have 11x equals negative 33. The opposite of multiplying by 11 is dividing by 11. So x would equal negative 3. Number 7. The opposite of a negative 11, I would add 11 to both sides. Those cancel, so I have 5x equals negative 25. Divide both sides by 5. X would equal negative 5. Number 8. The opposite of adding 5, I would subtract 5 from both sides. Those cancel, so I have negative 24 equals 6x. I would divide both sides by 6, and x would equal negative 4. Number 9. Subtract 5 from both sides. So I would have 4x equals 80. Then I would divide both sides by 4, and in this case, x would equal 20. Hopefully you are getting the hang of these by now. They should be getting easier for you. Number 10, this is just a one-stepper, the opposite of multiplying by 4. I'm going to divide both sides by 4. Those cancel. So x equals negative 5. The opposite of dividing by 4 would be multiplying both sides by 4. When I do that, my 4's cancel, so x would equal 12. The opposite of subtracting 7 would be adding 7 to both sides. So in this case, you would have x equals 27. Now it's going to start to get a little bit more steps to it. We're not even going to say complicated, just a few more steps added to the mix. So the first thing I would do here is distribute. So 4 times x is 4x, plus 4 times 6 is 24. On the other side, 2 times x is 2x, and 2 times 3 is 6. Warning bell should be going off. You can never have variables on both sides. I like to get rid of the smaller values. So since 2x is smaller than 4x, the opposite of a positive 2x, I'm going to subtract 2x from both sides. Make sure you're lining it up under the proper term with your variables. Those cancel, so I have 2x, bring down your plus 24, is equal to 6. Now it's like those problems we've been practicing with earlier. I'm going to subtract 24 from both sides. They cancel to give me 2x equals negative 18. And then the final step, remember the opposite of multiplying is dividing. So I divided each side by 2. So x equals negative 9. All right. I'm going to subtract 25 from both sides. These cancel, so I have 3x equals 30. The opposite of multiplying by 3 would be dividing both sides by 3. And in this case, x equals 10. Okay, this time I have variables on both sides. 2x is smaller than 4x, so I'm going to subtract 2x from both sides because the opposite of the positive 2 was a minus 2. They cancel. So I have 2x, bring down your minus 5, equals 11. Then I would add 5 to both sides. My 5's cancel to give me 2x equals 16. And my final step would be to divide by 2 on each side to give me x equals 8. Number 16, I have variables on both sides. 3x is smaller than 6x, so I'll take the opposite of 3x. So the opposite of a positive 3x is a minus 3x. Make sure you're lining it up under the appropriate term with the variable. So I would have 3x, bring down your plus 8, equals 26. The opposite of adding 8, I would subtract 8 from both sides. Those cancel to give us 3x equals 18. And the opposite of multiplying by 3, I'm dividing by 3 on each side to give me x equals 6. Number 17. I have variables on both sides. I have 10x and a minus 2x. So the negative 2x is smaller. So if I take the opposite, I would add 2x to both sides. My 2x's cancel to give me 12x equals 24. And then I would divide each side by 12 to give me x equals 2. First step here, remember always use the distributive property if you can. So if I distribute into my parentheses, remember you multiply. I would have 3x plus 3 times 8 is 24, gives me 48. Now it's like your normal problem. So the opposite of a positive 24 is subtracting 24 to both sides. Those cancel to give me 3x equals 24. If I divide both sides by 3, x would equal 8. 19 involves a fraction. Remember, fractions we don't really care for, so look at your denominator. I have a 2 and a 6. In this case, I'm going to multiply everything by 6. So I'm multiplying everything by 6, every single term by 6. And when you have two different values, like I said, make sure you look at both of your denominators. 6 is the larger denominator, and it's actually the common denominator. So remember, when you have the fraction, you could either type it in your calculator using the n over d button and then multiply it by 6, or think your numerator times 6 divided by your denominator. So 5 times 6 is 30, divided by 2 gives us 15x, plus 24 times 6 is 144, equals 10 times 6 is 60x, plus 9 times 6 is 54, divided by 6 gives us 9. So now, just like the normal problem we are used to doing, I have variables on both sides. I have the 15x and the 60x. 15 is smaller, so the opposite of a positive 15 is subtract 15x from both sides. The 15's cancel, so I have 144 is equal to 45x plus 9. Next step is to get rid of that 9, so I would do the opposite operation by subtracting 9 on both sides. I then would have 135 is equal to 45x. And my final step would be to divide both sides by 45. And 135 divided by 45 would give us 3. Alright, the next thing I would do for this one is I would multiply everything in your parentheses by 2/3. So if I multiply 2/3 times 2, 2 times 2 is 4, divided by 3 gives me 4/3 x, plus 2 times 9 is 18, divided by 3 gives me 6. And on the other side, I just have my 8. Remember, you only distribute into what is inside your parentheses. The 8 was not, so that's why we are not multiplying by it. Now I have a fraction. Let's get rid of it. So the 3 is in my denominator, so I'm going to multiply every single term by 3. Then I would have 4 times 3 is 12, divided by 3 gives me 4x, plus 6 times 3 is 18, equals 8 times 3 is 24. Now it's to the normal problem you all are used to doing. So I would subtract 18 from both sides to give me 4x equals 6. Divide both sides by 4. So my final answer would be 6/4, but if it's in reduced form, it would be 3/2, or technically 1.5. Alright, moving right along. First thing I'll do is distribute my 3. So 3x plus 3 times 7 is 21, and bring down your plus 4. On the other side, I'm just going to rewrite that. Now, I like to combine my like terms. So on the left side, I have my constants. I have a positive 21 plus 4. So I would have 3x plus 25. On the other side, I can combine my coefficients, my 6x minus 4x, to give me 2x plus 10. Now it's like the normal problem you're used to doing. 2x is smaller than 3x, so I'm going to get rid of the 2x, the opposite of a positive 2x. I would subtract 2x from both sides. These cancel to give me 1x plus 25 is equal to 10. Then I'm going to subtract 25 from both sides to give me 1x equals negative 15. And then I could divide both sides by 1, and x would equal negative 15. That was a biggie, but I'm sure by now you guys are comfortable with solving these. Alright, here we go. First thing I would do, and I'm going to erase this top problem a little bit so we have some more room. Okay, first thing I would do for this one is distribute. Always, always, always distribute first. So I can distribute the 4 into that and this negative into those. So I would have 4/9 plus 4 times x is 4x minus 4 times 1 is 4. On the other side, I would have 28/9. And remember, when you distribute that negative sign in, it's like multiplying by a -1, or you do the opposite of the value that is inside your parentheses. So since I have a positive 6, I'll write down negative 6. And since I have a negative 6x, I would write plus 6x. And bring down your plus 5. Now, I see fractions. I don't like them. My denominators are all 9, so I'm going to multiply every single term by 9. No matter what, multiply every single term by 9. Sorry, that's Maverick barking in the background if you heard that. Hold on, please. So I would have 4 times 9 is 36, divided by 9 is 4. Plus 4 times 9 is 36x, minus 4 times 9 is 36. On the other side, 28 times 9 divided by 9 is 28, minus 9 times x is 9x, plus 6x times 9 is 54x, plus 5 times 9 is 45. Now I can combine my like terms. So I have a 4 minus 36, which would give me 36x minus 32 equals, hold on please, I'm going to get Maverick. On the other side, if I combine my like terms, I could combine my negative 9x plus 54x, which would give me 45x. And then I can also combine my constants. 28 plus 45 would give me a positive 73. Now it should be getting used to a problem you remember or know how to do. So I have a 36x and a 45x on both sides. I'm going to get rid of the smaller one, so I would subtract 36x from both sides. These cancel to give me negative 32 equals 9x plus 73. I then would subtract 73 from both sides. Those cancel. To give me negative 105 equals 9x. And then if I lastly divide both sides by 9, I would get negative 105 ninths, which is technically negative 11.6 repeating. Alright, for the next one, I'm going to distribute again. So this negative sign goes there, and I would distribute the 1/2 into that. That would give me 7x. Remember, when I distribute just by a negative sign, I just take the opposite. So the opposite of a positive 3x would be a minus 3x. The opposite of a positive 5 would be a minus 5. And bring down your minus 8 equals half of 8x is 4x, and half of 20 is 10. Bring down your minus 7x plus 5. Now I'm going to combine my like terms, so I have 7x minus 3x, which gives me 4x, and negative 5 minus 8 is a minus 13. On the other side, I can also combine my like terms, so I would have a 4x minus 7x, which gives me negative 3x, and I can combine my constants. The plus 10 and the plus 5 gives me a plus 15. Now it should be back to the problems you know how to do. So I have variables on both sides. Negative 3 is smaller than positive 4, so I'm going to add 3x to both sides so I can cancel out. This would give me 7x minus 13 equals 15. I would add 13 to both sides, which would give me 7x equals 28, and then I would divide both sides by 7. In this case, x would equal 4. Alright, on to this part. Remember, all you're doing is plugging in your value. Your teachers in the past might have called it plug and chug, or substitute the number in for the variable. So all we're going to do is plug 5 in for wherever you see an x. I would do 4 times 5 minus 10 equals 2 times 5 plus 10. Let's see if this works. Four times 5 is 20 minus 10 equals 2 times 5 is 10 plus 10. 20 minus 10 is 10. 10 plus 10 is 20. Since these values are not equal, this is a no. And I'm going to have to stop it here and start recording on a new page because I'm almost at my limit for recording. So part 2 will be continued in a new slide or in a new video.